When you look at a factory's balance sheet, a net positive number at the bottom might look like a win, but in complex manufacturing, a surface-level financial victory often obscures the systemic operational failures on the assembly line. For operations managers, the ultimate scorecard for how well they handle raw inputs is the direct materials flexible budget variance. This is real-world data for Chowdown Incorporated. The bottom line shows a direct materials flexible budget variance of $84,562, marked as favorable. Management often concludes that both purchasing and production are functioning exactly as planned. However, an aggregate variance is operationally silent. It merges two completely different variables into a single figure: the price paid for materials and the efficiency of how those materials were used. To assign departmental responsibility, we have to separate that aggregate number into its constituent parts. We need to extract two isolated vectors. First, the price variance, which is driven by the purchasing department, and second, the quantity variance, which is driven by production efficiency. Relying on the total variance is a diagnostic error. True financial analysis requires us to mathematically isolate price fluctuations from production usage to reveal the reality on the factory floor. To understand the components of that $84,000 favorable variance, we will build a mathematical model for Chowdown's performance. Our baseline parameters show a budgeted standard price of $6.75 per unit and an actual output of 16,500 units. This diagram shows standard cost as a two-dimensional area, with the standard price on the y-axis and actual quantity on the x-axis. To isolate the purchasing department's performance, we first hold production's actual material usage constant. Chowdown did not pay the budgeted $6.75, they paid $7. This new top area is the direct materials price variance. It measures the financial penalty incurred solely due to the higher price, applied across every unit purchased. $7 minus the standard $6.75, multiplied by the actual input of 107,250 units, equals an unfavorable variance of $26,813. The purchasing department is generally held responsible for this unfavorable result, operating under the assumption that they simply paid more for raw materials than planned. An unfavorable price variance could also indicate that industry-wide prices have risen, requiring the company to update its standard cost expectations. There is also the possibility that the purchasing manager intentionally selected higher-cost premium quality materials to benefit production. Isolating the price variance reveals a $26,000 bleed in the purchasing vector, showing that the aggregate $84,000 favorable figure is already hiding a departmental loss. We now shift our focus to the production floor to calculate the second half of the equation, material usage efficiency. To isolate production's efficiency, we ignore the actual $7 price paid. We hold the price constant at the $6.75 standard. Chowdown's standard allowance for 16,500 units at 7.5 materials per unit requires a total budgeted input of 123,750 units. In reality, actual usage was only 6.5 units of material per product. This dropped the total input to 107,250. This eliminated area is the quantity variance. A savings of 16,500 units of material multiplied by the standard price yields a favorable variance of $111,375. This result typically suggests very high production efficiency, with workers reducing waste and spoilage far below their expected levels. However, highly efficient material usage can also stem from using slower, more expensive skilled labor. In that case, the material savings are simply being traded for labor cost overruns. Mathematical isolation reveals that the total variance is a departmental tug-of-war, a $111,000 production victory masking a $26,000 purchasing deficit. Before analyzing how these two variances interact, we must clarify what standard quantity actually represents in a manufacturing environment. Standard costs do not assume zero waste. Chemical evaporation, metal shavings, and routine spoilage are inherently built into the baseline metrics. This calculation involves a 3% evaporation rate, setting the standard allowance at 11.34 ounces. This evaporated material is normal spoilage, absorbed into the final cost, which factors in base price and shipping for a $12.47 total. An unfavorable quantity variance indicates that the operation has exhausted its pre-calculated allowance for waste and is now actively hemorrhaging capital. Because standard models already forgive normal waste, any variance isolated during analysis represents a true operational anomaly that requires immediate managerial investigation. Returning to the total picture for Chowdown, we can now view these isolated vectors side by side with the total variance. Looking at these figures, we can propose that these two variances share a direct cause and effect relationship. The purchasing department paying a premium directly enabled the production department's efficiency. Higher-priced, superior materials yielded less waste, resulting in the massive favorable quantity variance. There is an inverse scenario where a positive number in one department creates a structural deficit in another. Imagine a purchasing manager securing a large favorable price variance by switching to a supplier of cheap, low-tier materials. On the floor, the result is disastrous. Those cheap materials cause machine jams, excessive evaporation, and massive product rejection rates. The isolated favorable purchasing decision triggered a crippling unfavorable quantity variance, destroying overall profitability. Standard costing variances must never be evaluated in a vacuum. A financial analyst must isolate the variables, map their cross-departmental impacts, and recognize that optimizing one metric often comes at the direct expense of another.